Welcome back to Repair and Installation TV channel. Let's also explore how the world's largest and most beautiful bridges are formed. The construction process of installing the main tower blocks and closing the beams for the Kesennuma Bay overpass in Japan represents a pinnacle of engineering and precision construction. This intricate endeavor unfolds in a series of meticulously planned stages, where the deployment of advanced heavy machinery, particularly overhead cranes and mobile cranes, plays a paramount role. The journey begins with meticulous planning and site preparation. The construction site is cleared and leveled using heavy machinery, such as excavators and bulldozers, establishing a stable foundation for the impending towers. The foundations are then laid with the assistance of heavy drilling machines and pile drivers, ensuring that the towers will stand securely on a robust base. These initial stages set the groundwork for the awe-inspiring ascent of the overpass. The focus then shifts to the installation of the main tower blocks. Tower cranes, with their towering booms and robust lifting capacities, take center stage. These cranes, often anchored firmly to the ground or the construction site's main structures, become the industrial sentinels overseeing the gradual ascent of the overpass's main towers. Their lifting capacity is a testament to their engineering sophistication, allowing them to handle heavy loads with unparalleled accuracy. The installation of the main tower blocks is a meticulous process. Fabricated to exact specifications, each section is delicately lifted and maneuvered into its designated position by the tower cranes. The crane operators, perched high above the construction site in their control cabins, become maestros of a construction orchestra. Their skillful coordination ensures that each component of the main tower blocks is guided into alignment, guaranteeing a seamless fit during the assembly process. While tower cranes dominate the skyline, their fixed positioning can pose challenges in certain areas of the construction site. This is where the versatile mobile cranes come into play. Equipped with telescopic booms and robust lifting capabilities, mobile cranes navigate the construction site with agility, reaching areas inaccessible to their stationary counterparts. Their ability to move freely and swiftly makes them indispensable for specific tasks, showcasing the diversity of heavy machinery required for a project of this magnitude. As the main tower blocks reach considerable heights, the intricate dance of machinery intensifies. Overhead cranes, often gantry or bridge cranes, are introduced. These cranes, with their capacity to traverse horizontally along a rail or pair of rails, play a crucial role in handling and placing large components, such as beams, during the construction process. Overhead cranes are particularly adept at tasks that demand precise horizontal movement and positioning. The process of closing the beams, a critical phase in the construction, requires meticulous planning and coordination between the tower cranes, mobile cranes, and overhead cranes. Large precast or fabricated beams are carefully lifted into position, guided by the watchful eyes of crane operators who ensure that each beam aligns seamlessly with the existing structure. The overhead cranes, with their horizontal mobility, contribute to the precise placement of beams, enhancing the efficiency and accuracy of the entire process. Safety remains paramount throughout this phase. Rigorous safety protocols are implemented to mitigate risks associated with lifting and placing heavy components at considerable heights. Crane operators, highly trained and skilled individuals, meticulously adhere to guidelines, ensuring the secure and precise placement of each beam. The collaboration between ground crews and crane operators exemplifies the commitment to precision and safety, a testament to the meticulous planning and execution required for a project of this magnitude. The orchestration of tower cranes, mobile cranes, and overhead cranes transforms the construction site into a dynamic theater of progress. The overpass, with its gradually closing beams and soaring main towers, begins to define the skyline, signaling a new era of connectivity for Kesennuma Bay. The legacy of the heavy machinery involved in this phase stands tall in the form of a structurally sound and aesthetically impressive overpass. As the final beam is placed, The completion of this phase marks a significant milestone in the construction of the Kesennuma Bay overpass. The towering main towers and interconnected beams stand as a testament to human ingenuity and the seamless collaboration between advanced heavy machinery and skilled construction professionals. The Kesennuma Bay overpass, with its intricate dance of cranes and precision construction, becomes more than a physical structure. It becomes a symbol of progress, connectivity, and the triumph of engineering excellence over geographical challenges. The Kesennuma Bay flyover, a marvel of modern engineering nestled in the scenic landscape of Japan, stands as a testament to innovation and connectivity. Spanning the picturesque Kesennuma Bay, this architectural masterpiece serves not only as a vital transportation artery, but also as a symbol of resilience and progress for the region. Rising majestically above the bay's waters, the flyover's design seamlessly blends functionality with aesthetic elegance. Its strategic location addresses the unique geographical challenges posed by the bay, offering a crucial link that enhances regional connectivity and accessibility. The flyover represents a triumph over the limitations of terrain, providing a smooth passage for vehicles and facilitating efficient travel within the area. As a beacon of progress, the Kesennuma Bay flyover not only enhances transportation infrastructure, but also contributes to the economic and social development of the surrounding communities. The flyover represents a vital lifeline, fostering regional growth and facilitating the flow of goods and people across the bay. Its completion marks a significant chapter in the ongoing narrative of Japan's commitment to cutting-edge infrastructure and sustainable development. Whether admired for its engineering ingenuity, appreciated for its aesthetic appeal, or valued for its role in regional progress, the Kesennuma Bay flyover stands as an iconic structure that transcends its utilitarian function, embodying the spirit of resilience and advancement in the heart of Japan. The construction process of the Osman Gazi Suspension Bridge in Turkey involved several stages, each requiring meticulous planning, engineering precision, and collaborative effort. Here are the key stages of the construction process from start to finish. 1. Foundation construction. The construction of the Osman Gazi Suspension Bridge commenced with the strategic placement of caissons, formidable structures that played a pivotal role in serving as the foundations for the soaring bridge towers. Caissons, often referred to as watertight chambers, were meticulously crafted to withstand the aquatic forces of the Gulf of Izmit. These massive structures were engineered to ensure buoyancy during transportation and sinking, combining both structural robustness and hydrodynamic efficiency. Transporting the caissons to the construction site was a logistical ballet, requiring precision and coordination. Specialized vessels were employed to ferry these colossal foundations from their fabrication yards to the designated location in the Gulf. The careful navigation of these vessels, laden with the weighty caissons, reflected the delicate orchestration involved in bringing the essential building blocks of the bridge to their intended destination. Upon arrival at the site, the next phase unfolded with the deliberate placement of the caissons on the seabed. The process involved submerging the caissons to the specified depth, ensuring a secure and stable foundation for the bridge towers. This underwater ballet required a synchronized effort, with engineers employing advanced positioning systems and underwater technology to guide the caissons into their designated positions. The act of sinking the caissons was a critical juncture, as it marked the literal groundwork for the monumental structure that would rise above the Gulf. The caissons, anchored firmly to the seabed, formed the bedrock upon which the bridge towers would ascend. This phase exemplified the marriage of engineering precision and maritime expertise, as the caissons, once floating on the water's surface during transport, seamlessly transitioned into their submerged roles as foundational pillars. The construction team navigated the complexities of the underwater topography, ensuring that each caisson found its designated position with millimeter accuracy. The success of this foundational phase set the stage for the subsequent construction milestones. The construction process of the Osman Gazi Suspension Bridge in Turkey involved several stages, each requiring meticulous planning, engineering precision, and collaborative effort. Here are the key stages of the construction process from start to finish. 1. Foundation construction. The construction of the Osman Gazi Suspension Bridge commenced with the strategic placement of caissons, formidable structures that played a pivotal role in serving as the foundations for the soaring bridge towers. Caissons, often referred to as watertight chambers, were meticulously crafted to withstand the aquatic forces of the Gulf of Izmit. These massive structures were engineered to ensure buoyancy during transportation and sinking, combining both structural robustness and hydrodynamic efficiency. Transporting the caissons to the construction site was a logistical ballet, requiring precision and coordination. Specialized vessels were employed to ferry these colossal foundations from their fabrication yards to the designated location in the Gulf. The careful navigation of these vessels, laden with the weighty caissons, reflected the delicate orchestration involved in bringing the essential building blocks of the bridge to their intended destination. Upon arrival at the site, the next phase unfolded with the deliberate placement of the caissons on the seabed. The process involved submerging the caissons to the specified depth, ensuring a secure and stable foundation for the bridge towers. This underwater ballet required a synchronized effort, with engineers employing advanced positioning systems and underwater technology to guide the caissons into their designated positions. The act of sinking the caissons was a critical juncture, as it marked the literal groundwork for the monumental structure that would rise above the Gulf. The caissons, anchored firmly to the seabed, formed the bedrock upon which the bridge towers would ascend. This phase exemplified the marriage of engineering precision and maritime expertise, as the caissons, once floating on the water's surface during transport, seamlessly transitioned into their submerged roles as foundational pillars. The construction team navigated the complexities of the underwater topography, ensuring that each caisson found its designated position with millimeter accuracy. The success of this foundational phase set the stage for the subsequent construction milestones. 3. Pylon erection. The elevation of the Osman Gazi Suspension Bridge towers heralded a critical juncture in the construction process, ushering in the phase of pylon erection. With the towers ascending majestically, the subsequent task was the precise installation of the bridge pylons. The towering vertical structures that serve as the integral connection points between the bridge deck and the intricate network of suspension cables. These pylons, towering above the construction site, were not merely structural elements, but pivotal components that would bear the weight of the entire bridge and serve as anchor points for the complex system of cables suspending the deck. Crafted from reinforced concrete, each pylon's design and construction were undertaken with a keen eye on structural integrity and load-bearing capacity. The process unfolded as a carefully orchestrated sequence, with cranes and construction machinery lifting sections of the pylons into place. The ascent of each pylon mirrored the tower's gradual climb, a testament to the synchronized efforts of the construction team. The strategic placement of these pylons, positioned with geometric precision, ensured both stability and aesthetic harmony, contributing to the bridge's iconic silhouette. As the pylons reached their designated heights, they stood as towering symbols of progress, their presence signifying the impending integration of the bridge's elements. These vertical support structures, rising against the backdrop of the surrounding landscape, foreshadowed the intricate interplay between form and function that would characterize the bridge's completion. The successful completion of the pylon erection phase paved the way for the subsequent steps in the construction process, including the installation of the suspension cables. Each pylon, standing tall and resolute, represented a tangible achievement in the journey from concept to reality. The Osman Gazi Suspension Bridge, with its soaring pylons, began to assert itself as a testament to human ingenuity and collaborative effort, bridging not only physical spans, but also embodying the spirit of innovation that defines iconic infrastructure projects. 4. Cable installation. With the towers standing tall and the pylons reaching towards the sky, The construction of the Osman Gazi Suspension Bridge progressed to a pivotal stage, the installation of the suspension cables. These cables, an indispensable component for supporting the entire bridge deck, were the intricate threads that would weave strength and stability into the suspended expanse. The cable installation phase marked a delicate ballet of engineering precision, where each cable was meticulously tensioned and attached to the towers, giving rise to the distinctive catenary shape that characterizes suspension bridges. The suspension cables, crafted from high-strength materials designed to withstand immense loads, were carefully transported to the construction site. The sheer magnitude of these cables, often stretching across the entire length of the bridge, required strategic planning and coordination. Once on site, the cables were delicately unraveled, resembling colossal strands of a grand architectural tapestry. The installation process began with the meticulous attachment of the cables to the bridge towers. Each cable was secured with precision to designated anchor points, ensuring uniform distribution of the load. The tensioning of the cables was a critical step, requiring a fine balance to achieve optimal structural integrity. This process involved carefully adjusting the tension in each cable to bear the anticipated loads while maintaining the desired curvature of the catenary. The installation of the suspension cables was a testament to the intricacy of suspension bridge construction. The precise measurement, careful tensioning, and secure anchoring of each cable were paramount to ensuring the stability and safety of the entire structure. The process required a harmonious collaboration between engineering expertise and the advanced machinery employed for cable installation. As the cables were systematically tensioned and aligned, the bridge began to emerge in its complete form, suspended between the towers and pylons in a graceful equilibrium. This phase bridged the tangible connection between the vertical elements and the suspended deck, transforming the Osman Gazi Suspension Bridge from a skeletal framework to a fully realized and functioning structure. The completion of the cable installation phase brought the project one step closer to its grand unveiling, where the convergence of engineering prowess and artistic vision resulted in a bridge that not only spanned physical distances, but also stood as a testament to human innovation and determination. 5. Bridge deck construction. With the Osman Gazi Suspension Bridge's towers reaching skyward and the intricate web of suspension cables delicately anchored, the construction phase seamlessly transitioned to the creation of the bridge deck. The deck, a crucial component linking the towers and supporting the roadway, marked a significant milestone in the realization of this monumental structure. The process of bridge deck construction involved the meticulous assembly of segments, often crafted using precast concrete, and their methodical lifting into position. The segments of the deck, typically precast to ensure uniformity and structural integrity, were crafted off-site in controlled environments. This prefabrication allowed for quality control measures and streamlined the on-site assembly process. As the precast segments were transported to the construction site, the assembly of the bridge deck began in earnest. Cranes, meticulously positioned, lifted each segment into place, creating a seamless integration of components. The assembly process unfolded like a complex puzzle, with each segment interlocking with precision to form a continuous load-bearing surface. The choice of precast concrete for the bridge deck segments was not only a testament to its durability, but also a pragmatic decision to expedite construction. The use of precast elements minimized on-site casting time and facilitated a more efficient workflow, reducing the overall construction timeline. The lifting and placement of each deck segment demanded careful coordination, as construction teams worked in concert to ensure the alignment and connection of elements. The interplay between man and machine as cranes hoisted massive segments into position mirrored the collaborative spirit that defined the entire construction endeavor. 6. Stay cable installation. With the towers standing tall and the bridge deck gracefully suspended, the construction of the Osman Gazi Suspension Bridge progressed to the pivotal phase of stay cable installation. These additional stay cables played a crucial role in enhancing the stability of the bridge, serving as integral connections between the bridge deck and the towers. The installation of these cables not only contributed to the structural integrity of the bridge, but also played a key role in distributing the load evenly across the entire expanse. The stay cable installation process was a meticulous operation that required precision and coordination. Crafted from high-strength materials capable of withstanding significant loads, the stay cables were carefully transported to the construction site. The lengths of these cables were tailored to precise specifications to ensure optimal performance. The installation began with securing one end of each stay cable to the bridge deck. Construction teams, working at elevated heights, delicately attached the cables to designated anchor points on the deck, establishing a secure connection. This phase demanded a careful orchestration of equipment and personnel to ensure the seamless integration of each cable with the deck structure. The other end of the stay cables was then meticulously attached to the towers. This process involved precise positioning and anchoring to ensure that the cables contributed effectively to the overall stability of the bridge. The careful tensioning of each cable was a critical step, ensuring that the load distribution was balanced and that the bridge remained resilient in the face of various environmental forces. As the stay cables extended from the deck to the towers, they created a visually striking pattern, further enhancing the aesthetic appeal of the Osman Gazi Suspension Bridge. The interplay between the stay cables and the suspension cables formed a network of tensile elements that bore the weight of the bridge while also contributing to its overall architectural grace. The completion of this phase marked the final touch in transforming the Osman Gazi Suspension Bridge from a skeletal framework to a fully realized and resilient infrastructure. Throughout the construction process, rigorous quality control measures were implemented. Inspections were conducted to ensure compliance with safety and engineering standards. After successful testing and approval, the Osman Gazi Suspension Bridge was officially opened to the public. The inauguration ceremony marked the completion of this significant infrastructure project. Each of these stages played a crucial role in transforming the conceptualization of the Osman Gazi Suspension Bridge into a tangible and operational structure, contributing to the connectivity and development of the region.